mix here of skills and experience.
Great.
Okay.
I'm very sorry I can't be there in person today. And when I look out my window, it's a blue sky and sunny. I do find it hard to understand why my flight got canceled, but it did.
That's all right. Well, we're glad you can connect with us via WebEx, and we'll try and let you know when we have some questions here in the room.
Okay. So
Thanks.
One of the things, thanks for having me here. I mean, one of the things that I did want to talk to you about. Oh, I hear a lot of echo, which is I just have to get used to the echo for a second. Okay. So one thing I wanted to talk to you about was to help you save the pain of going through the a bad data lake experiment. So can you guys still hear me? Can you hear me? Yeah?
Yes.
Oh, okay, great. Thanks. Okay, cool. Okay, so I'm just going to kind of move ahead here. Just trying to get used to it. There we go. So I want to show you a little bit about how we at MarkLogic have been thinking about data in the enterprise and how you might use an operational data hub to integrate some of that enterprise data and maybe to even get a little bit more value out of your data lake initiatives. So starting out, here's a simple view of data in the enterprise. Maybe you recognize it. There's a left half and a right half and some stuff in the middle. And the left half has all the stuff that runs the business, like ERP. And on the right, you have the business observation systems, like maybe the data cubes you create every night off your order invoicing system. Well, now that nice simple picture looks like a map of the last 4 nor'easters, drilling into what you have to do in each of these enterprise data technology zones. You see the amount of effort and complexity that's required just to hit some of the high points. And I don't know, maybe you guys covered this morning. I wish I had been there to see, but just looking at the ETL part of it. So there's usually a lot of stored procedures there, a lot of tribal knowledge about data types and data purposes all wrapped up in that code. Master data includes operations, master data management includes operations like creating golden masters, deduping, other kind of cleanup and configuration and care and feeding intensive functionality. Data from multiple sources is merged according to rules, and you have to track those rules and the lineages and all the source information. So, and then also on that side, you've got the service-oriented architecture bus, and these can be real-time messages or requests by one application to another that may produce or update data in one of the business systems. Then kind of moving over to the right in the observe zone, you have all the delivery components to support analytics applications that run off of Snowflake schemas, for instance. So I can't hear you because I think we are working on the audio. The audio is better without hearing you, but does this look familiar to everyone? I mean, does this make sense so far? Yeah? Okay. Okay, I saw a couple of flashing hands there. Thank you. Okay, so let's move it ahead. So let's just get back to the simplified view. So here's a simplified view again. Let's kind of look at it another way. So in that middle zone where you're shipping your data from the run the business zone to the observe the business zone, you've got a lot of costly work going on. It's mostly having to do with integrating relational schemas to one another, creating new kind of Uber schemas that many stakeholders have to agree on, and then kind of pulling in and relationalizing or orming or shredding or whatever you want to call this kind of operation, the unstructured stuff that you now need to accommodate. So, and then one little point I wanted to make is the unstructured data that's in this diagram is probably not to scale. You know, objects in the mirror appear smaller than actual size. The point is that there's a lot more unstructured data today than what's represented in this diagram. So as you're doing all that work in the middle, of course, your ability to observe operations in real time, or even near reasonable time, sort of disappear in that rear view mirror I just mentioned. And you get longer and longer times between running and observing the business. Okay? Okay? So, one method that, and some of you guys might be familiar with this, that architects use to analyze problems that occur in these settings might remind you of your inner 6-year-old who wants to know why the sky is blue. The premise of this method is that if you ask why enough times, you get to the root of a problem. So it takes about 5 whys usually, which is why we call this the 5 whys exercise. So in this case, an investment bank wants to deliver a post-trade processing system, but it's taking them like 2 years to get started on development, just to get started. So if you dig into the reason why development is stalled, you wind up sort of pointing at the data modeling. The data modeling all has to be done up front. And that's holding up the entire rest of the project. So if we, all of us, add up all the time we have spent with huge groups of people in conference rooms discussing schema, we could easily understand why people are looking to do this differently. I know that I've spent a lot of time, you know, just kind of discussing whether such and such a value should be a varchar or a blob or something else like that. Whether something should be a long or an int, you know, and should that be included in the schema, should it not? We've all had these kind of conversations. So another example is based on a mortgage reference data project one of our banking customers implemented. They could not get their customers accurate or timely information on their mortgages. So they couldn't service them very well. And they sure couldn't upsell them or cross-sell them on new mortgage products very easily. Again, you see that the root cause is that it's too hard to integrate this data in a relational model. As I recall, it was too hard for this bank to even deliver this with a column score, because that too was too restrictive to provide the value they needed to justify the cost of integrating these systems. It was taking them far too long to develop the functionality with a column store and to provide the infrastructure for that. So what customers are trying to do is kind of rationalize that data journey from the run the business side to the observe the business side you still need some kind of shock absorber between those two data zones, and you can't, just leave it blank like this slide. So what we do, the way we think of it at MarkLogic is, we put in ODH in here that provides that cross-zone functionality. And it does it in a secure, sort of governable way as a platform beneath this entire environment. So all the systems that produce data in the run zone are going to be adding to those as-is ingestion flows in the ODH, which you can see in that top operation that's called out there in the column, the blue ODH column. So this is a schema-agnostic platform we have here. So we don't worry if we don't know all the details about how the different data sources are going to relate to one another or what formats they might be in, including sort of like delimited flat files like CDC data, or even unstructured or documents like HL7 health records or insurance policy events for the Hartford peeps on the left side of the room there. The bus, can simply, the SOA bus here, like this can simply fork messages into the ODH or do some signal boosting on its own and push a high value set of messages into ODH. And systems like the CRM and your CRM and ERP systems, or your GA systems even, their data can be ingested as is without worrying about how you're going to integrate it first before you can start tracking it and getting some data from it. So underlying all of this is a secure platform that provides for safe sharing, which is how we kind of like to think about security now. I never liked, I was a CTO once, and I never liked to think about security as restriction. I like to think of it as, kind of rules for sharing. So like, you can you can borrow my G.I. Joe in the sandbox, but don't rip his head off, and kind of stuff like that. So the other thing that this platform provides is provenance and lineage information about these data movements, where this data comes from, how it might be processed or changed or integrated with other data sets. And this, of course, is stuff that regulators really like. If you're a bank, I don't know where folks are coming from in the audience, but I'm sure many of you have run across regulatory sorts of intrusions or even or even just inquiries on what you're doing, and you need data to deal with that. Okay. So the ODH provides this sort of bow tie pattern, the many in, many out sort of operation. And it doesn't really necessarily mean, actually, that your whole organization is a bow tie like this. There are a lot of places in your enterprise, across that whole landscape, where this many in, many out pattern exists. And you can start to put those together and get rid of what that big pile of stuff in between. Is it ETL? Or it could also be a spaghetti diagram with a bunch of point-to-point connections. I've seen that a lot. So all those kinds of instances in your enterprise data landscape, those can be fixed by thinking about it in terms of an ODH pattern. Now, we aren't, at MarkLogic, we aren't the only ones to find value in this approach. Jeffrey Moore and Chi Lu, the Chief Operating Officer at Baidu, created this system of operation pattern. And you can read about it on LinkedIn at that link there. I can I'm sure we have some way of sharing slides or the links at some point. So for those of you who don't know, I think everyone's heard of Baidu, but Geoffrey Moore is the guy who wrote the book about crossing the chasm, where he defined, where people are on the innovator curve, the technological innovator curve, and so he's a kind of very influential thinker in enterprise architecture, and he and Qi Lu came up with this independent of MarkLogic, though he's now speaking at MarkLogic World. Plug, if you guys are interested in what I'm talking about, there's a lot more at MarkLogic World, which is coming up in June in San Francisco, and urge you guys to take a look at that. And if your managers are into letting you travel, getting out there. Geoffrey Moore will be there. So what Geoffrey Moore has done here with this pattern is, maintained those run and observation zones, which we saw earlier. Those are in the middle of the diagram here. He and Qi Lu, they added these emerging zones on the left and the right, this system of engagement zone, and which I guess would characterize as kind of IoT, which produces a lot of logs and a lot of sensor data, things like that, and systems of intelligence, the system of intelligence zone on the right side, which would encompass things like machine learning. And one of the ways that I've seen it be used a lot, a system of intelligence zone being set up and created, is where people are doing, say, semantic enrichment of their content or of third-party content that they get, and of applying taxonomies to that content, which can then be used to link it together during operations and during presenting that content to users. So, for instance, a mortgage, someone who has a mortgage repository would be perhaps looking through content, looking through looking through their incoming documents for business entities or any other sort of financial entities that they might then link to a taxonomy of financial concepts that could then be used to help users connect to other content in their other systems from their mortgage system. So that sort of is happening today, and that's happening in many industries, from financial and insurance industries through to entertainment and media industries, which use semantics to relate articles and video clips, let's say, to related articles and video clips, like just taking everything having to do with government and then finding not only government articles, but then also articles about specific aspects of the government and presenting those to users. So that's a system of intelligence, and then the system of engagement, of course, we mentioned having to do with sensor data. For instance, energy companies which want to do diagnostics on pipelines and send robots into those pipelines with sensors to determine where there might be corrosion inside the pipeline, and they emit a tremendous amount of data and detail about what's happening inside a pipeline that needs to be analyzed. So, you have these new zones that want to provide, that are here to provide better and more timely feedback to people who are running the business, but they just produce more and more kinds of data and more quantity and a higher quantity of data. And so you kind of need this system of system of operation underneath it all to kind of maintain all the linkages between these other 4 systems and make sure it's all working well and all of it is governable. So this pattern for an operational data hub has been developed from real-world requirements from MarkLogic's ongoing customer projects. And our customers are like Fortune 500 companies. So we are working closely, our on-site consultants work closely with our customers' IT departments, development groups, to capture sort of common patterns that we use then to kind of conceptualize this entire framework. So at the high level, the framework view sort of comes down to a 3-step process. So the first step is data ingestion. So you have your source documents from multiple sources. They all land into a MarkLogic staging area. And that's all about loading data as is, as I had mentioned earlier, from disparate systems. And then you move across the diagram from left to right into the second step called data harmonization. And that's where this is where MarkLogic's real value comes in, because MarkLogic's the whole secret of MarkLogic and the whole strength of MarkLogic is indexing. So we can make indexes of all this stuff in the staging area, and we can expose those indexes with languages like xQuery or JavaScript or Java, so that you have a variety of source documents that get standardized using these languages into entity instances, where an entity could be a customer, a patient, an insurance policy, and so on. So the entity instances that we create here in the harmonization step are documents which are formatted using this envelope pattern. Again, this is a real common field. This is commonly used in the field to capture standard attributes related to the entities. And you can think of the envelope pattern just really simply as a document that encloses the original document and adds some metadata around it, decorates it with metadata or linkage data. So this is where the complexity of data silos, where you have different models, different schemas, different languages, where this all gets turned into sort of standardized data structures in MarkLogic that are made available in, as you move to the right of this diagram, in the final area, what we're calling the final area, where you have to harmonize and index data. And then the third step of this process really is serving, making the data accessible to a number of consuming applications, which could be operational applications, analytical applications, and so on. So all these applications have different needs in terms of how they want to access the data, what data formats they can handle. Schema on read is another aspect at which MarkLogic excels, and this is where the notion of schema on read is that instead of front-loading our entire data hub processing with schema creation and schema, schema validation, we're doing that as applications need to consume the data. So I need data in schema A. We're going to transform the data as is, because we have all these indexes that we can use for transforming into an instance of schema A, and we're going to deliver it to the person who's asking for schema A. this lets us defer the work of creating those schemas to the point at which business needs them. And that deferral is what allows us to build this very quick, build quickly this environment in which you have run the business, which you have all these 4 zones of data being moved across into finally delivering value to the business, where we don't have to sit for 2 years and wait for a schema to be developed. We can say, oh, line of business, you need this data in this schema. Well, we can just quickly and incrementally build that out for you in the schema on read, and then and still have all the data that we might require to build other line of business requirements and such. So that's the true, that is what I think of as the true value of this pattern. It allows you that incremental delivery. So best practices captured here. So I think the separation of the staging and the final area are, typically there are 2 different databases, and they have, because you kind of, just like you had this OLAP and OLTP kind of separation in the previous world order, you now have this kind of, separation between staging and final, where you need 2 different kinds of indexes, and they manage different attributes, and they may have different security policies and such. And there are different life cycles that you manage across both of those. The concept of the envelope pattern is another best practice here. Now, I had mentioned briefly what envelopes were, and we don't have to dive too deeply into them. If we get a chance, I can actually show you one later on. But the concept of the envelope pattern is that you capture, sort of standardized attributes without throwing away the original source data. So you can always trace the lineage of how you got to a particular value that your application is using. And then you have sort of implementation best practices here too, which we document and describe in our documents. Just having some guardrails around this. There's an operational data hub framework, which is available on GitHub in MarkLogic's public area for you to use and set these up. And that data hub framework provides you with some guardrails and structure about how to actually code this out and make sure it works to scale and everything. Okay, so now what I want to do is I just want to click is what I want to do. I can do that. Sorry, I'm having a little trouble. There we go. Let's click that. Okay. Now what I thought I would do is talk to you a little bit about some of the use cases for data hubs. Who are using data hubs, and what are they doing with them? So Aetna is a large health insurer that provides coverage for 23 million people through 1 million different providers. So this means they process billions of claims every year, and they also have to manage HR data for about 35,000 of their own employees. They also recently acquired Humana, which probably a lot of you guys know about, in 2015. That added a huge source of data. And then there was another merger and acquisition which they did just recently, which also where they also have got to cope with all this data. So Aetna's IT organization was getting a lot of pressure from the business to integrate all their HR data into a central place and have it delivered to downstream systems. So for these other kind of real-time applications, and they were also doing batch analytics on it. And the feeds were like employee data, payroll data, employee evaluation data, and a lot of other systems, actually. So a lot of this data currently existed in traditional relational models, particularly IBM DB2. So that was their whole thing. So for IT to integrate this data, I don't know if any of you guys have, who comes from DB2 shops? Anybody? No? Okay, thank you. People are listening. Sometimes it's hard to tell, like when you're doing this remotely, if people are actually actually listening, because I don't hear a lot of the room noise and stuff. So for IT to integrate the data, it just meant, you know, this DB2 data, a lot of point-to-point data exchange solutions with lots of complicated ETL, and all of that stuff had to be written up front. You know, it was that classic, like, we have to do a lot of upfront relational work. So, but, you know, Aetna decided that this would be costly, time-consuming, and they thought it might even be impossible, actually, because of the constraints. But even if they did it, they thought they would just have a really brittle system, because every time one of these data feeds changed, you had to sort of accommodate, you had this kind of cascading effect across the whole system, and they just thought that would be too expensive and sort of impossible. So they chose to do a data hub with MarkLogic because they wanted to take advantage of a flexible data model that they could develop in a more kind of agile fashion, overcoming these ETL challenges that we've been talking about. So they developed a canonical data model to communicate between these different formats. So that made it possible for them to decouple the source data from the target systems. And this was an important development for them because it meant they could reuse a lot of code, be resilient to change, and manage all of these growing sources of data and all of these volumes and types of data. Now, it might sound to you like creating a canonical representation is a lot like ETL and coming up with like a master schema. And it is, you're right, except there's one big difference. Like, you don't have to come up with the entire schema. You only need to come up with a portion that allows you to achieve a particular business goal with a particular data source. So, and then you can incrementally add and add other sources, other data, other goals, other APIs on top of that, and keep a pace with what's required by the business. So again, the difference between a canonical envelope representation, where you're taking a canonical representation of the data and putting it in that envelope portion of the data of an entity document, as I had described before, and of doing ETL, is that when you take the ETL approach, you have to figure it all out ahead of time. When you do this kind of canonical envelope approach, you can do it incrementally and even version it. Like, we have one banking customer who built one version of a canonical envelope, and then they added like a version attribute to their canonical form, and they just query the data. Their APIs will query the data based on that version. As they add new versions, and they can take the end user applications, and as they decide they need to, they can bump up the versions that those APIs are using to read that data. So it's a pretty good way to manage and stay ahead of the needs of business. Here, you know, Aetna needed ACID transactions, which is another big selling point of MarkLogic. You know, I don't want to hammer too much on selling and stuff, but but the ACID transactions here are required, and they're something that NoSQL databases has traditionally been pretty bad at. In fact, they haven't been able to do it. MarkLogic's been able to do ACID transactions since the beginning, so that is pretty cool for an application like this, where they needed that data consistency, but they also needed security and auditability and transparency. So the results of this were that the results were that they had this complex ingestion that they managed, and this was like something like 24 different HR data sources with and that's 24 sources with 140 separate feeds though. And the data is consumed in 50 systems over 200 different formats, and all those formats are egress from MarkLogic in that schema on read way that I was talking about before. This is a system with like a couple of terabytes, I think, of data in it, and it has a throughput of I've got my cheat notes here with these numbers on it, with 50 gigabytes of data per day. So a big result of using MarkLogic was that Aetna could deliver this solution less than a year instead of 5 years. And they used, if they were to use relational technology, the project would have eaten up, they thought about 50,000 hours. I don't know if that's true or not, but with MarkLogic, it took about 6,000 hours with our consultants. And so that's a big difference. So let me just move on to next one. Just navigating here a little bit. So healthcare.gov is a very similar situation, except in this case we're taking all different kinds of data relating to ensuring your health. So health insurers have data about their plans. The government agencies have data about customers' eligibility, and the eligibility and the health insurance plans come together in this kind of health insurance exchange, and those exchanges were systems that were very difficult to do with relational schema. In fact, the government started to do this project with relational database, and they failed, and that's the only reason they started looking at a NoSQL kind of way of doing this. Dealing with all of those different data formats was really the story here. That was what drove them to try to do to need to do this with MarkLogic with a NoSQL platform. So the other thing I wanted to bring out here on this slide is that Oregon did try to go to market, with their own exchange, and they think they wound up suing the relational database vendor who they went to market with, because they just couldn't get it done. Anyway, so again, I don't want to make this a MarkLogic commercial. So let me move on a little bit here. Just a little bit of the results here. They they met their congressional deadline for delivery, as you guys know. 280,000 concurrent users, and the success that I just have to say that I feel very proud to be a part of something like this, because this this is a system that actually provides something that people really need. It's not like some, you know, it's not like how many widgets did we sell. It's really, you know, let's use data to make people's lives better. No matter what you think about the politics, I mean, whatever it is, we wind up using data to create something that people really need, and so that is a pretty cool result for me. And it was the largest personal data integration government project in the history of the Republic. So there was that was a pretty big effort and required a different approach. So it really did require this approach that I've been talking about through the presentation, where you've got a bunch of sources on the left side and a bunch of outputs on the right side, and you know, in the middle you need some sort of hub for putting that all together. Okay, so I will move on from this one. And I'm not going to spend a lot of time on this. It's very similar. You guys will recognize the pattern: the left side, the right side, the data hub in the middle. In this case, this is a bank which started with us doing, doing this trade hub. This was after the financial crisis. This business, you know, at this bank, faced problems trying to comply with new regulations. And so they had this trade derivatives business, which they had to make transparent to regulators. And so each of the databases which dealt with these derivatives had its own method for ingesting these trades, and the development time was required for the development time that was required for each new derivative type coming into the system was prohibitive. You know, they couldn't move quickly enough to make these changes and supply the data to the regulators and keep their business running. And another thing is they couldn't get the aggregate view across their whole business. They couldn't analyze their total market exposure, and exposure is something, you know, it's risk exposure is something I'm sure the insurance folks in the room will be very sensitive to. They couldn't, you need data to be able to know risk, and they couldn't analyze they couldn't get the data to analyze their risk. So they also had a pretty costly, in this case there was like a lot of DBAs. There were like 20 or 30 DBAs maintaining, I'm gonna say Sybase databases. I believe it was Sybase databases in this case that were just too, they were just unstable and couldn't perform the way they needed them to. So they developed this consolidated trade store, and they integrated all those sources into the trade store. And instead of having these siloed trading systems, they took all this stuff like core derivatives data, rates data, foreign exchange, or you guys might know it as FX trade data, all of this feeding into a single MarkLogic system, a data hub, where it's processed and sent to downstream systems. So again, this gave them flexibility. We'll just go ahead to the slide here. Sorry, I'm having a little trouble. Oh yeah, there we go. Yeah, so anyway, so right, so I was saying that this gave them flexibility. They were able to store the data from multiple formats, but also to deliver it in any schema that was required by the downstream systems. And they could do this from this single unified system. Remember that 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 image from the Jeffrey Moore slide, where the system of operation is a platform underneath all these other systems, and the way that MarkLogic uses an ODH as a platform for security and governance. So they did that, and that was a very, very good benefit for them, providing them with this flexibility. They could then tune up the performance so they could get the regulatory, they could meet the SLAs that they needed to get the regulators their information, get them supplied with everything they knew, and move on and do their business. And then they also can do this. What I think is another really important thing is get this holistic aggregate view so that they can manage risk better. So that was a big. Those were the benefits of JPMorgan doing that. And then earlier I had mentioned the mortgage data repository, the mortgage reference data repository. So they came to us then to do this mortgage reference data repository using the same architectural approach, which is to take this data hub and be able to put all this stuff together and look at it that way. So I wanted to close this part of what I'm doing with a definition, and this is our enterprise CTO's definition of an operational data hub. And those bolded terms are his. So I'll just leave it here. I don't want to read it for you because you guys can read it, but to pull out some of the important terms there, multi-model data, a multi-model data repository. So it's important that you have a system that allows you to index all of the kinds of data that you are going to be managing, that allows you to access those indexes through a single API, a single view, no matter what the underlying data is. Otherwise, you are going to be stepping into that sort of data lake, some data lake problems, let's say, or challenges, where you wind up with a whole bunch of stuff in your data lake, but then no good way of getting a view of all of it or getting access across the entire lake and understanding what is all there. And that's kind of what you really do need in an operational system. You need a view of everything. And that's what having a multi-model capable engine gives you. So cross-functional is another important term here because you have data science on the one hand wanting to sort of sandbox this whole thing and look at run ad hoc queries, do what they want to do. So you need to be able to give them access and let them have fun. And then you also need the folks who are going to be developing data applications to deliver to lines of business to be able to create that kind of through line through the system out to the lines of business. So those are two different kinds of users, two different kinds of operations. You need to be able to have the data be able to service both of those things. And I will leave the rest of that for your own, reading pleasure. And I wanted to quickly, I don't know, we've done almost an hour, and this would be my last slide. And what I was thinking I might do, if you guys were interested, is to quickly do a little live demo of data harmonization using our Data Hub framework. Is everyone up for that, or are you guys done on Friday?
Yeah, I'm getting head nods.
While you're setting that up, let me just scan this room and see if we have any questions here for you. Anybody have any questions for Frank?
Take it.
Oh, here.
Hey, this is Ram from Wells Fargo, and I'm part of Enterprise Data Architecture team. Can you hear me okay?
No, I think it would be if someone repeated the question, or maybe I went on while asking.
We're looking for a mic.
Okay.
Wherever he's picking up the voice from. So my question is operational data hub analogous in concept to the traditional operational data store, the concept that we have from several decades, if not, right? The difference being that it's more of a relational paradigm, and here we're talking about the document paradigm. Is that a fair comparison in terms of the pattern you employ underlying the MarkLogic platform?
Yeah, so I think what I hear you asking me is what is the difference between the traditional kind of ODS, operational data store, and what we're talking about with this operational data hub? And so, my answer to that is that in the traditional ODS, you are typically doing this kind of relational workflow, which is a waterfall workflow that says, okay, we're going to do schema design up front, and we're going to do all this data modeling exercises up front, and then we're going to kind of go and get our data and start to bring it into the ODS. In this case, what we're describing is less a kind of functional difference, because you're still bringing data in and you're still providing it, to line of business. But what you're doing here is we're changing the kind of urgency and the order of things. So you move all the data into the data hub, and then you use the data hub to incrementally do data modeling. You don't actually, with an ODS, it's typical, I think, that you're doing data modeling and then putting it in the ODS. Here, you're putting stuff into the ODH and then incrementally doing data modeling as it's required by the business.
So just to follow up on this question, so when you talk about data modeling for the hub, how does that look like? Is that creating the envelope you talked about for the document? Is that part of the modeling process?
Yes, that is. And what I would like to do is, if we have time after the questions, I'll actually show you a document that is an envelope, and then I'll show you how we kind of model the metadata for that envelope. So you'll see exactly what it looks like. But yeah, it's a document with metadata elements.
Thank you.
Hi, we have another question for you.
You.
Hey, Frank, it's Mike P. from the Hartford.
Hi, Mike.
One of the benefits I see with ETL and having that relation, that ODS model in between, is it forces you to do data profiling and lets you know what you're storing. If you're just taking from the source systems and storing it as it is, how do you recommend inventorying what you're storing so you can find and populate your reports down the road?
Yeah, that's a good question. And I mean, so what some people do is they actually use sort of data cataloging systems, and they'll take the data feeds they'll take data feeds metadata from those data cataloging systems into the ODH. What other people do is they'll take reference data that they have and put that in the ODH, and that's what, say, JPMorgan Chase did with its mortgage repository, and use that to track the location of assets and everything. If you are thinking, okay, I have a whole bunch of stuff I don't know, I have to kind of crawl through it and figure out what I have, so that's another, that's certainly a process you can do with the ODH, where you sort of put everything into the ODH. You don't think of the ODH as a repository of output. You kind of think of it as a sort of second fork, where you actually get your data from the source producer as a the sort of fork, and then it goes to so there's two forks coming out of that producer, and one goes to the ODH and one goes to whatever system of record requires it.
Great, thank you.
Anyone else? Okay, Frank, I think we're ready for your demonstration.
Oh, you are? Okay. Well, I'm not ready yet. Oh.
Well, I can't sing and dance, so please be fast.
Okay, let's see. I'm just trying to get a hold of. There we go. Let me just end this. Let me just go to here real quickly. There we go. Stop sharing that.
So the question is in the room, do we have any MarkLogic customers in the room? The answer.
Oh, yeah. What's the answer? Do we have any?
No, we don't. Nobody raised their hands. Let's go that way, Frank.
Maybe no one wants to admit it.
I don't think that's it. I don't think that's it.
Okay. Let me get this started here.
But Frank, just while we're doing this, maybe you can talk and click at the same time. I'm not sure everybody in the room understood that MarkLogic was behind the success of Care.gov, right?
Yes, that is true. There was some. You guys might remember there was a lot of press about its initial stumbling and bumbling. That the system was buggy and it couldn't log people on, and much of that had to do with another database vendor whose relational system was not scaling properly, and had to be shut down and re-indexed, and MarkLogic, when MarkLogic came into the architecture and we turned on the Data Hub, we were easily able to recover from some of the other infrastructural sort of issues, like network issues and things like that, which were causing problems with the other pieces. So we ultimately took over the entire data layer. So we have all of the customer information, all of the exchange information, all of that stuff is managed by MarkLogic now. It's not shredded into relational databases. So, yep, every transaction that goes through there comes through MarkLogic.
I'm sorry, we have a question for you.
I'm just wondering if there's still a need in shops where they have MarkLogic to still keep relational databases.
I'm sorry, if there are still, I didn't quite hear the question.
In the shops in the companies where they've implemented MarkLogic, is there still business reasons to keep a relational database?
Oh, sure. Yeah, that's a great question. I love that question. So, I don't know if you remember, one of the slides I showed this kind of bow tie diagram, and I did mention that this is not the entire enterprise, but there are places in your enterprise where this kind of many in, many out happens, and in a lot of cases, some of those inputs are going to be relational databases. So those kind of systems are still very, very much in evidence, people, and you know, there's 40 years of technology behind there. There's a lot of legacy. There's a lot of optimization around that go into those systems, and so there are things that they do very well. And it's just that when it comes to agility, security, and some scalability, you know, they can be more costly to kind of scale up and make that stuff happen with than taking this kind of data hub approach.
Anybody else? Any other questions? Okay, we're ready.
Okay, so now I am going to. This is like very ad hoc, kind of, not ad hoc, but you know, you'll note that it's somewhat live. It's like live TV. So I mentioned that. Okay, can you guys see my browser here?
Yes.
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 Okay, cool. So is it big enough? Because that's a little tiny here. There we go. This is the window I want you guys to see. You should see like a Git project, a GitHub window here, and what I'm showing you, we're going from the 30,000 foot view down to maybe down to maybe 5,000 feet here. What you got here is a page that shows a project that is in MarkLogic's public area. So MarkLogic has a community area, and if you go to GitHub and you search MarkLogic community, you will find this and some other pages. And this page is the Data Hub framework. The Data Hub framework is a set of patterns and code which allows you, and a Java Spring Boot application, which allows you to get a data hub up and running fairly quickly. So it's meant to, it's meant to kind of bootstrap you, jumpstart you on building data hubs. And so what I did is I went to this page and I cloned the project, and I built my own data hub by running the jar file, and I'll show you what I did here. So this is a project that I cloned, which I'm going to show you. Share this application. I've got to get something at the door here. 1 second. Okay, so what you're looking at now is IntelliJ, and you're looking at a project, which is a data hub project. And in this data hub project, you see a bunch of stuff that the bootstrapper, which I downloaded, created, a bunch of these files, most particularly these Gradle build files and stuff. But I also, excuse me 1 second, guys, I gotta write this. I also downloaded some sample data, which is some human resources data. And you're going to notice it in those JSON files and in those CSV files, which I have. One of them is highlighted right here. This is the sample data that I'm working with. What my scenario is that my company has merged with another company, and I have some personnel data, HR data, from 2 different systems that I have to merge together. I'll be right back. I'm going to leave for 10 seconds. Okay.
I think we're waiting for
I'm back. So I have this. So we have some data that came from a system that produces nice JSON files for us, which are these kind of property value files that look like this. They're pretty much self-describing, the way we like to say documents are. So you can clearly see stuff like the last name of this person. We have a salary here and a start date for them. And we have another one of these, same situation. And those are the nice little JSON files we got from Acme Tech. That was one of the companies that we merged with. We also got some files from Global Corp, and they look like more like this, which you guys are probably also familiar with seeing from dumping CSV files from relational systems. So we've got this employee table that we pulled out of our Global Corp HR system, and we want to take these employees and merge them with the nice with the JSON data that we got from our other from Acme Tech. So we've got two companies with two different kinds of data. Does that make sense? And we want to put them together. So I think what I've done for you is shown you the two different kinds of data that we're going to be working with. And I haven't shown you what the final outcome is meant to be. So what I will do is switch to my browser, where I will show you another window, which is this window. And I'm now I'm gonna actually log out of that window. 1 second, because I want to show you from the very beginning what happens here.
So Frank, in your merging of these two different data sets, did you do any pre-analysis of how they could be integrated? In other words, do they share name and address or those kinds of things?
Yep, I'll show you that shortly. That's a very good question. What I wanted to do is show you the quick start that we have created, which is a UI that you can access from that GitHub page that I showed you. Again, a Java Spring Boot application, and it connects with MarkLogic, and it does all the kind of setup and workflow handling that workflow automation that you might want when you're sort of building a quick data hub. So you get a screen that looks like this, and you can choose a project, and I have a couple of them that I've been playing with. And one of them is this Data Hub demo, HR Data Hub demo, which I've just shown you in my other development environment window. So now that I've picked one of these projects, I will be able to click through this UI and get this project up and booted here. It's asking me to log in because MarkLogic is secure and we don't do anything without security. So I'm now logging into this data hub. I'm going to take just a second. And should be logged in. There we go. That's strange. Okay. Let's go there. Yeah. I think that was a UI bug or something. But in any case, I told you it was live. So I've been playing with this. So there are some documents in my database, and I'm going to clear them in a second. But I want to go back to the development environment and look at the data, just to address the question about did I look at the structure. So one of the things that we have, the very first field in this Global Corp data is an employee ID. So I've got these IDs for each employee. Each row has an ID. Each row has some address information. It has a title, and it has a hire date. And it doesn't have any salary information. I have a separate table for the salary information, which actually is joined on this ID. So that's interesting. So I could presumably put these two tables together into one document that has an employee name and salary, much like these documents look, where there's actually the name, the ID, and some salary history here. So I want to somehow get a consistent picture across both of these data sets about employees' start dates and salaries. And I want to get those in a sort of form that is consistent, that my downstream applications will be able to contract with and get that form back through an API that they will be able to predict. Okay, so very simple data sets. You're going to have a lot more complicated data sets in real life, and this is a demo, so it's simple. And hopefully we can follow it along with it pretty easily. So this is the data that I'm going to want to ingest into my data hub, these two data sets. And so what I'm going to do is go back to my data hub. I'm going to clear all the data that I've already put in there by hitting this little icon here. And it's going to go off and clear this data, and it will eventually get these totals down to zero. It's doing that, going off and doing that in the background. There it goes. It's done. The other aspect of the Data Hub framework, you might recall that I mentioned our Data Hub pattern has a couple of main steps to it. And the first step was ingesting this data as is. So what we have done with our Data Hub framework is we have a notion of flows. And we have created flows here for ingesting data and for harmonizing the ingested data. The first part is that we have defined an entity, and we've done that on our data modeling screen, which I will show you here, but yeah, here we go. Okay, it's this is a bug. There's a bug here, and that's why I was reluctant to click on this. So this is a kind of a graphical user interface for defining an entity, and you can put properties in the entity. The bug is that the properties that belong here aren't in here, and I'll talk to you about those as we build the envelope. But once I've built an entity like this, I will go to my flows page and start defining how I'm going to pull data into that entity definition. And in this case, I've got my load Acme Tech flow, my load Global Corp flow, and those are going to be pulling these data sets in. The load Acme Tech flow will load this data, and the load Global Corp flow will load this Global Corp data. So let me go and just do that, and then we'll take a look at what we did. So I'm gonna click on the Acme Tech flow, and I'll go through a little bit of the setup for how we get this data ingested in MarkLogic. We use a tool called MLCP, which is MarkLogic Content Pump, which is a Java application that is open source and available for you guys to use. But it's a supported project and it's the mainstay of ingesting data into MarkLogic. So we use it for a lot of stuff. We've bolted it into the Data Hub framework here and given you some options to set for pulling data in. So we got this Acme Tech data we want to load, and we see a little file system browser that shows some of it. But there are some other options we can set here, like what type of data it is. In this case, we're going to say that it's documents, what document type it is that we want to output. We're going to say JSON, and there's not a whole lot more. And this is a command line. This shows the command line, the command line command for MLCP to run this independently. But we're not going to run it independently. We're just going to run it from here, and we're going to run this import. Before I do that, I want to go to the browse data section and show that we've got no data in this database. We've got nothing in this staging database at all. and it's sitting there searching. It should stop doing that soon, but again, yeah, so we've got no data. So live data here, running on my laptop with 800 other things. So forgive me for little things like that, but no data. Okay, cool. So let's get some data in here. So let's load this Acme Tech data, and let's come down here and run it. The cool thing about the way that this was implemented is that it uses an automation harness called Gradle, which allows you to kind of write tasks and run them automatically from the command line. I'm not sure we actually got that input. There we go. So you could actually do all this from the command line using Gradle as the automation tool, and that's kind of a standard way that people are building pipeline applications and development applications. So we just loaded some data. So let's go over to our jobs window and see that we actually got the data in here, and that's going to load whatever jobs it just ran, and there's our job, and it says finished and there's no errors, so that's really cool. So let's go and browse some of that and see what we actually got in there. And I talked about how MarkLogic has got some very powerful indexing. So what we're able to do is, to do this kind of faceted view of what we pulled in, and we're faceting on entities, and we're faceting on flows, and we're faceting on collections. So we actually pulled in these two JSON documents, and we added some envelope structure to them. Let's take a look at one of them. So here is the document with its envelope wrapper around it. You'll notice that the root element or root property is the property envelope, and it contains a couple of children, headers, triples, and it contains a child called instance. Within that instance child is the original data that we pulled out of the file system for this particular instance of the employee entity. So our flow put this envelope around it. And let's go and do the same thing for the Global Corp stuff. Now, recall there we had CSV, so we have to set a few different options here to deal with the delimited text. And what our options will do is create a JSON document for each row in that employee CSV table, and it'll also join using the when we do our harmonization flow, we'll join the salary data to the employee data. So let's actually run this and pull that stuff in. So now we're pulling in those CSV files, and this will take a few minutes longer because there are a bunch more records in that CSV file, and it takes a little bit longer to create that number of documents. I think we're done already, though. No, we're not quite done yet. Should be finished shortly. I can get a trace for this job if I want. I'm gonna just do a refresh. I think I probably don't have to do that refresh. Yeah, it's finished. Okay, it's finished. So we've got that CSV data in there too. So let's take a look at that real quick. And you'll notice too that I've got these different, I've got different facets. I mentioned the facets earlier, and so what these facets are allowing me to do is to group the data that's in the database by the jobs that I ran to pull it in. So that's a kind of an important concept, because what you frequently need for, you need this for lineage. You also may need it for regulatory purposes, where, hey, where did that stuff come from, and when did you get it in here? So that's something that we can do. We can track that pretty easily. So we pull up this particular collection of stuff that we got out of the CSV file, these employee records. Let's take a look at one of those. And yeah, so we've got a little bit of salary, base salary information there, and that's what a row of that data looks like. So those are sort of different schemas, right? We've got sort of this base salary here, and let's go look at the other set of data and see how salaries are represented there. So let's take a look at the Acme stuff. And it doesn't say base salary. It's all stuck in this salary history element with a property name of salary, which is quite different from the other one. So how are we going to get a view of salaries across our entire set of employees? So that's where we have done this harmonization step. The harmonizer, I'm not going to go into great detail, but it runs through several steps here, creating each one of these, creating the content, the headers, and the triples areas of that envelope. When I run it and we take a look at it, you'll see what I mean. It's running the job. It's done with that job. And let's harmonize the global corp stuff as well while we're at it. Okay, so now let's take a look at what we've got. And in this case, since we harmonized this, we've moved from a staging area to a final area, because we've harmonized it. We've made some decisions about what we want our data to look like, and we are now ready to put it where it can be served. And that's in our conception, that's the final area. So we're taking a look at that, and let's take a look at, we've got two collections here. We've got the Acme Tech and the Global Corp both harmonized. So let's take a look at what we've created. So we've actually created some new properties in this headers element. We've created a salary and an employee ID and a date of hire property, and so those are the canonical versions of the canonical representations of those important facts that I care about across these two data sets. So let me show you the other data set. And that would be in the Acme Tech. So here also, I'm looking at the wrong, sorry guys, looking at the wrong database, because I expected something different there, because I was still looking at staging data. Now I'm looking at final data. So I just looked at, let's look at this Acme Tech stuff. And here again, we've got the canonical version of the data that I care about, even though this instance, the original form of the data is different. And I have kept all the instance data in case at some point I decide I want to pull some other information out of here or deliver this information in a different form. I can always go back and do that by running another harmonized flow. And so this, now I'm gonna complete this by showing you the what I can actually do across this data. So here is another application that ships with MarkLogic, and this is the query console. It's a web application that lets you basically run queries against MarkLogic and display their results. So what I'm interested in doing is looking at my HR demo Data Hub, which I just put data into. And let's explore that quickly. And we see that all this data that I was just looking at in the browse data area of the Data Hub framework is all here as well, is all here. And it lists collections and stuff like that. And I can click on one of these and take a look at it down here. And I see, yeah, that's all the stuff that I got. So now the cool thing is that I can actually run some interesting queries on this. Like I could actually say, well, when it got up here in this window is I'm interested in the date of hire after a certain date, and I want to see who's making the most money. So what I could do is actually run a query now using the canonicalized fields across both of those data sets and get a data set that has my employees who are making more than $60,000 who were hired in the last half of 2015. So that's the full circle. Even more is that there is a built-in REST API on the final Data Hub, the Data Hub final database. And what I'm going to do is actually go there too. Once I figure out where that is, which won't take me long. Oh, I don't want to go to Query Console, sorry. Let's do admin. So I'm jumping around a little bit. I hope that I made that that kind of full circle connection for you between sort of ingesting data. We ingested it. We took a look at it. We decided that there were some fields we wanted to represent in a canonical fashion. We ran harmonization code on them, and then we queried it in Query Console. So I'm going to leave it at there. I'm not going to confuse this by going to the REST interface. But the one thing that I will show you is that what Data Hub Framework did when it created this project for me was it built automatically these code stubs in this plugins directory. For every entity that I defined, I got a directory, and inside that directory, I got code stubs for harmonizing and for inputting data. So let's take a look at one of these harmonizers real quick, just to give you a flavor of it. I'm not going to go line by line for code. I think this one's kind of interesting, I believe. It's the other, sorry, this harmonizer is better. So what we're looking at right now is some JavaScript code. And this is JavaScript code that, I mean, it could be JavaScript, it could be xQuery, depending on what I specify. I specified JavaScript for this one because I knew most of my input data was going to be JSON, and it's kind of easy to work with JSON and JavaScript. So I built it this way. what this code does is it goes off and collects a list of IDs from those CSV files and builds a list that it will then pass to the next plugin, who will do queries on that list and decide what to do and build a new document for each one of those lists, for each one of those IDs rather. So leaving you with this is probably not what I want to do. I'm going to leave you with looking at the final REST API, which you get out of the box, which is 8051. Cool. Okay, cool. So here is the kind of default interface that every MarkLogic REST server has, serves up to you when you create it. If you just go to the REST server port, you'll get this page, and it will contain links on it that have URIs to various out-of-the-box REST operations. So if I, for instance, was interested in seeing some search results, I could click this link, and it would show me this not very interesting or readable-looking bunch of search results. However, this is a JSON structure that your consuming app would probably be pretty happy with. Anyway, so that's kind of all I had, and I'm interested in hearing from you guys if this was useful to you. Which part did you like best? Which part was you could have done without? You know, I'm happy to hear questions as well.
Thanks, Frank. Thank you very much for the demo. We don't often get vendors who come in and give us a real demonstration of their product. And since we don't have any MarkLogic users in the house, I'm presuming it was pretty interesting to all of us. I know I'm familiar with Informatica and all the relational database management systems, but not this particular approach to an integrated data hub. Any questions in the room for Frank? All right. Well, Frank, thank you very, very much. I'm sorry, we would have loved to have had you here in the room with us. I'm sorry about your flight, but I hear you're coming to Charlotte, so at least those of us at the Hartford will be able to meet you next week.
Yeah, I'd love to see any of you guys there next week when I come down. So.
I'm thinking you're probably going to meet some people in my group, and maybe I'll have a chance to come by and say hello. Great.
Well, thanks for having me.
Oh, sorry.
Yeah, thanks a lot, guys.
Thanks. Have a great weekend.
Bye. You too.
I'm sorry. So this is the conclusion of our meeting. As I said, sometimes we were able to have vendors come in and speak to us, so it's a good opportunity for us to hear what's going on in the new product world. I think I kind of pointed out some of the board members that are here today from DAMA. So as you leave, if you have any suggestions for future talks, future speakers you'd like to hear, future subjects that you'd like us to cover, please drop us a note or speak to us. And also, I did want to mention, we love Lowe's and we love their facilities, but we might take a wild hair and have our next meeting with Microsoft off of Arrowwood. The proposed day is either June, it's the third Friday in June. I forgot if that's the 22nd or the 23rd, but of course we'll be sending out some email to you. And please go to the DAMA Carolina's LinkedIn website where you can also find out about our next meetings. So again, thanks for coming, and hope to see you in the summer.
Bye.
Visitors need to be escorted out.
Visitors need to be escorted out. There are several of us here that will help with that. So let us know when you're ready to go.
I'll end the meeting now. I think that's over.